Hi guys, my name's Kelly and today I'm going to be giving you a brief rundown on my project focusing on the abundance of wildlife and vertebrate pest species in southeast Queensland using various trapping methods. The use of sand plots and other various trapping methods give land managers good quality data to be able to effectively manage and control pest species whilst conserving native wildlife. The project aims to identify relative abundance of wildlife and pest species, wild dogs in particular, within Gold Coast City and Gatton Shire. The study sites at Gatton Shire included Thalma, Burkett, Haggadorn and Ergon sites. In Gold Coast City we surveyed the northern area, which included Lower Beechmont Conservation Area, Wongawallan, King Parrot Reserve, Crystal Creek and Cedar Creek Reserves. A number of Elliott pitfall, cage and passive and baited soil plots were all used to gauge the number of species present and the relative abundance. Animal capture and presence data was collected by UQ students within the Gatton sites. City of Gold Coast pest animal officers collected the data and processed the animals that were captured within the Gold Coast City sites. Leghold trapping targeting wild dogs and foxes were undertaken by the City of Gold Coast pest officers in the northern area of the Gold Coast. Trap sets were chosen depending upon evidence of recent pest animal activity through pre-trapping monitoring and the observation of tracks and scats. Moving on to the results. In Gatton Shire, 6 species were caught in Elliott traps over the survey period, with Antechinus flavipes the most abundant. Here we have the results in Table 1 for the relative abundance of species captured in the Elliott traps and the Gatton sites. Looking at Table 2, pitfall traps revealed low species abundance, although diversity was greater than in both cage and Elliott traps. Trichosaurus belpercula was the only species caught in the cage traps over the survey period. Calculating chi-square tests for the passive and baited soil plots in Gatton sites, significant differences existed. For example, P equaled 0.017 for all macropod species across the board. For Trichosaurus belpercula, P equaled 0.0001, and the presence of wild dogs significantly differed between passive and soil plots. Gold Coast trapping data from 2014 to 2015 shows that there is a significant difference between species abundance. Results from our camera trapping surveys indicates that Lower Beechmont Conservation Area has the highest abundance of wild dogs. Figure 1 shows a higher species diversity and lower wild dog activity in the King Parrot Reserve area, whereas in Figure 2, the Lower Beechmont Conservation Area shows a lower species diversity and a much higher rate of wild dog and fox activity. Leghold trapping in these areas have been relatively successful, with 12 dogs and 40 foxes captured between 2014 and 2015. However, according to camera trapping data, the abundance of wild dogs and foxes have decreased, though not significantly, in these areas to date. In conclusion, survey results indicated higher species abundance and diversity in sites where there were lower wild dog activity rates and abundance. This information is essential for conservation managers to be able to effectively manage pest species and being able to conserve native species on a local scale. Thank you.